Hi, Atan Kosi. Hi, Karabo. Welcome back. We're going to be finishing off the 2019 paper one paper that Marilise was also doing with you. Hello, Swelile. Lovely greeting. Thank you so much. Who else is with us? Oh, just you guys for now. Okay. Anyway, what I'd like you to do in the meantime is just look at question number 9, and the formulae are given to you, which is nice to know. Hi, Timothy. Welcome to our lesson. And let's see if you can do at least question 9.1 on your own. All right, but we'll get underway just now. Question 9.1 and 9.2 are super easy, and then we get to 9.3, which is a little bit more difficult. Okay, so just get started on that matrix. Hi, Cheeto.
Hi, sorry I'm a little late.
It's okay, don't worry. Thank you for joining us.
No problem.
Okay, so we're just going to get started on question number 9. Just while we're waiting for everybody to arrive, please try question 9.1 and 9.2. I'm hoping everybody's able to do those questions, but I will obviously go through all of this with you. Question 9.3 is a little bit more difficult. Okay, so I hope you guys have got your calculators with you and a book to write in, and obviously a pen to write with as well. Please also make sure that you've got your calculators. Okay, Matrix, I'm just going to wait 2 more minutes and then we can get underway. Welcome to everybody who's just joined us. I've just encouraged the other Matrix to read the question and to attempt question 9.1 and even 9.2. You can certainly start looking at 9.3 if you are finished, and then we're going to go through this together. All right, so these are the questions that weren't done from the 2019 paper 1 that Marilise was doing with you. Okay, so Matrix, I'm sorry to interrupt you if you are busy, but let's get started because obviously time flies by so quickly, and this is going to be the last Q&A session, I think, now. Mind you, I'm saying that I actually don't really know. Okay, so in the very first question, we were asked to calculate the volume of a sphere, and the nice thing to know is, Matrix, is that with questions like this, if they do ask you to do a min-max problem, so this is a word problem following on from calculus, where you'd be doing maximum and minimum. Sorry, just 1 minute. Jethro. So just 1 moment.
Ooh, I think somebody's in trouble.
Sorry, I just had to shut my front door because my neighbors were making a little bit of a noise. My apologies. Anyway, I'm back now. Okay, so this question, as I was explaining, this is the sort of question that would follow on from calculus. Once you finished with the graphs, then there would be a question like question number 9. So either they would ask you something to do with minimum and maximum, so like with a sphere or a rectangular prism or some kind of shape, or they could ask you a question about motion, velocity, that kind of thing. Anyway, this is what was in the 2019 paper, so that's why we're going to do this. So the first question really is very straightforward. It just involves us subbing straight into the formula. Does anybody have an answer that they're happy to share? Anybody manage to do 9.1 on their own and they're happy to tell us what they got? Are you feeling shy? Tired? Okay, so volume of a sphere, matrix, means that this is the formula that we would be subbing into. So it's 4/3 pi. And then the radius in this case is going to be how many units? Okay, it says over here it's going to be 8 units. All right, so 8 like that. And then obviously we would need to cube our answer. All right, so the first one here, I ended up with a volume of 2144,66 centimeters cubed. Not that you would get penalized for not having the centimeters cubed, but there we go. Nice to always put our units in. And because this was out of 1, there would obviously just be 1 mark for the answer. Is that okay? Any questions? Easy enough? Okay, how many people managed to get, oh, there we go, Danao. Thank you very much. Same answer. Okay, cool, Danao. Thank you. Right, now it says to us, show that r squared is equal to 64 minus x squared. All right, so what they're wanting us to do here, what does it feel like to you? Well done, Cheeto. Good answer. What do we think this question wants us to work with? I mean, if we have a look, we can see that we've got a right-angled triangle. Okay, so this question over here is insinuating or implying that we need to work with the theorem of Pythagoras. So yeah, same, theorem of Pythagoras. All right, so the right-angled triangle that they're asking us to look at is this little one. So I'm just going to draw, it's this little one here. Okay, and this side here is also 8. So O, I know it doesn't have a letter, but OC is also 8, just as OA is 8. They're both radii. All right, so working in that triangle, we would then end up, let me just choose a better color. We would then end up saying that r squared, which is adjacent side squared plus adjacent side squared, x squared, is equal to hypotenuse squared. Oh, my squares are terrible. My apologies. All right, and then the reason for that would be Pythagoras, and making r squared the subject of the formula means taking the x squared over to the other side. Okay, so they obviously wouldn't give us a mark for the answer, the mark would have to be on this line over here. Okay, r squared plus 8x squared equals 8 squared. I'm sure if you just wrote that and you didn't write Pythagoras, that you would get all the marks for it as well. Okay, now this is where the fun begins, so to speak. All right, question 9.3. Look at that matrix. It is out of 7 marks. That's a lot of marks, isn't it? Okay, so let's have a look at what they're asking us. They're telling us to determine the ratio between the largest volume of this cone and the volume of the sphere. So when we read that, when they ask us to determine a ratio, they want us to compare 2 quantities, in this case, 2 volumes. Because it's a ratio, we have to work with whole numbers. Right, so we're not going to be working with, or when I say we can work with a fraction, but we can't have them both as fractions. We have to compare a whole number with another whole number. If you want to write it as a fraction, you can write it as the one over the other, but the quantities themselves can't actually be fractions. So asking us to compare the largest volume of the cone. What do the words largest volume of the cone imply? What are they trying to say to you here without actually saying it? Anybody know? Bearing in mind that this is a question about optimization. No one got any ideas? The largest volume? So what is the word? So if something is the biggest that it can possibly be, what's another word that we use for that in maths? There we go. Something about a maximum and a minimum. Quite right, Cheeto. Okay, something about a maximum. So this would be, so largest volume is just another way of saying maximum volume. All right. So they want us to maximize the volume of the cone. Do they want us to maximize the volume of the sphere? Yes or no? We're maximizing the volume of the cone. Do we need to worry about maximizing the volume of the sphere? Maybe that's a little bit of a difficult question, but anyway, the answer to that is no. All right, they just want us to maximize the volume of the cone. All right, so we don't have to worry about maximizing the volume of the sphere, but we obviously have to know which object we are working with regards to our maximum. Okay, so we need to maximize the volume of the cone, and we've got our formula there. So the formula for the volume of a cone is 1/3 pi r squared times h. Okay, so we've got some of this, right? And the h we're going to have to sub in from the diagram. So it's 1/3 pi. We know what r squared is from question 9.2. So that's going to be 64 minus x squared. And now we need to sub in the height. So the height means the perpendicular height of the cone. All right, the perpendicular height of the cone. How can I describe the perpendicular height of the cone matrix? What would that end up being? Anyone? What's the perpendicular height of the cone? Okay, in other words, the line that they are asking us to refer to here, matrix, is this one. The perpendicular height of the cone. From here, from B, all the way up to A. All right, how long is that line? It's going to be, can anyone tell me? X plus X plus, exactly, Cheeto, perfect. All right, so it's going to be X plus 8 units long. All right, so now what we want to do, remember, this is what we want to maximize. We want to maximize volume, all right, with respect to X, all right? So now, before we are allowed to go ahead and take the derivative, the rules tell us that we have to get rid of brackets, we have to get rid of divide lines, and we have to get rid of roots as well. So we need to get rid of those brackets. That's the easy part. We're going to do that by using FOIL. Okay, so let's write 1/3 times pi. We can write as pi over 3. And then when we remove our brackets, that's going to leave us with, okay, so multiplying these together, we would end up with 64x plus 512, because that's what 64 times 8 would leave us with, minus x cubed minus 8x squared, like so. Right, so now that we have multiplied out our brackets, we can go ahead and we can differentiate. All right, so what I'm going to do is I'm just going to move the screen down a little bit. Hopefully there we can still all see what's going on. Okay, so now I want to tell whoever's marking my work that I have differentiated. So now, instead of writing v equals, I'm now going to write the dv over dx. Okay, so I'm differentiating the volume with respect to x. And this means that I need to multiply my coefficient by the number in front, and then I need to take 1 away from the coefficient. All right, so in doing that in my first term, I'm going to end up with 64 pi over 3. Does that make sense to everybody? Because I've taken 1 away from the x, so it becomes x to the power of 0, so that means that this term does not have an x in it. What's going to happen to the second term? What happens when I differentiate with respect to a constant? What do I get? Zero? Zero. That's right, Silindile. I get 0. Okay, so I'm not going to write anything here, all right, because I'm not going to write plus 0 as part of my answer. Okay, so now what I want to do is I now want to differentiate the next term. So again, I'm going to multiply the exponent by the coefficient. So that means I'm going to end up with minus 3 pi over 3 x squared, like so. And then with the very last one, again, I'm going to differentiate by multiplying the exponent by the coefficient, and I'm going to end up with negative 16 pi over 3. And then there I have to take 1 away from my exponent, so I'm going to be left with x, just like that. Is everybody happy with where I got this statement from that is in pink? Is there anything that you want me to explain? Daneo, quite right. We now need to make it equal to 0 because that's what we do for maximums and minimums. Cool. Thanks, Karabo. I appreciate the input. Thank you. All right. So now what we want to do is we want to take this and we want to make it equal to 0. Quite right. Okay. So next step, make the derivative equal to 0. And what I could do, matrix, at the same time, is I could multiply everything by pi, multiply everything by 3 and divide everything by pi, which means that I'm going to end up with 64 minus 16x, let's just get it into order, minus 3x squared. Does that make sense to everybody? So I've done two things in one. I've multiplied each term by 3, and I've also divided each term by pi. Is that okay? Just to sort of try and make things a little bit easier for us. Now I want to factorize. Normally, what I find easier, Matrix, is to get, if I'm working with an x squared term and I want to factorize a trinomial, I find it easier just to make that into a positive term. So I'm going to change that around. I'm going to make it into 3x squared plus 16x, and then here it would have to be minus 64, like so. All right, so I've changed the sign of the minus 3x squared to positive, same with the minus 16x, and the same with the 64. They've all changed sign. Now I'm ready to factorize. If you find factorizing complex trinomials like this a little bit difficult, you're welcome to use the quadratic formula. The only rule is that when you are working with a quadratic formula, you have to show that you've subbed in. Okay, now the metric markers are very, what's the word? They will mark certain things wrong. So what I'm trying to say is this, is let's say you decide you cannot factorize this trinomial, but you're too lazy to show that you've subbed everything into the quadratic formula. If you write your factors like this, so for example, if you worked out what the values of x were for this, what it would tell you is that one of your values for x, it would do this. Now, if you do that, all right, in finals, they will mark you down for that. You are not allowed to write your brackets like this. Okay, so what you have to do is, if you are going to do it that way, you've got to make sure that you're setting it out correctly. So as far as your factors are concerned, you have to write 3x over here. Over there, you would have to write x. In this case, it would be 8 and 8. All right. And which one is going to be positive and which one is going to be negative? So that one would have to be positive. That one would have to be negative, and then we're back on track. Okay, so you cannot write x minus 8 over 3 as a factor. Okay, so they will mark you for accuracy on this line as well. Something that a lot of matrics do is that they go straight from this to just working with this, and then the 0 disappears. You have to show that it's equal to 0. You're going to get marks for that. And the 0 has to stay there in every single line until you have finished factorizing and you've now solved. Okay, so that's a very common problem. So that's why I'm pointing those two things out to you. All right, so now based on this, we've got two solutions for x. Either x is equal to 8 over 3, or x is equal to negative 8, right? Now, something else that we see matrics doing on a regular basis is disregarding answers, right? So you've got to make sure that when you disregard one of the solutions that you get, that you've done it for a reason, all right? So in this case here, a lot of the time what matrics do is that they cancel stuff out just because it's negative, right? And that's not always the right thing to do. But in the context of this question, given that x represents a length, let's go back and have a look here, okay? Remember, x is a length. It is the distance from B to O. Is it possible in the context of this question for x to be negative? Can distance be negative?
No.
No, distance can't be negative. So in the context of this particular question, we are then going to disregard this answer. We're not going to scratch it out. We're simply going to put a line through it and say that there is no ways then x could be equal to negative 8. We're almost there. Okay. Now that we have solved for x, we're a little bit closer. Remember, what they wanted us to do is they wanted us to compare the volume of the cone, all right, to the volume of the sphere. right? So now let's go ahead and go and do that. We can either write it as a fraction, or we can write it as a ratio. It really doesn't matter. Let's just move the chat box out the way. All right, I'm going to write in the space over here on the left-hand side. Okay, so the volume of the cone compared to the volume of the sphere. Okay, so volume of the cone is 1/3 pi. And now we need to sub in these values that we've worked with. All right, so let's just go up here and have a look. All right, we are supposed to be subbing in r squared. Okay, remember r squared is 64 minus x squared. Do you remember that from question 9.2? So that means we need to work out a value for r. All right, so just quickly here on the side, or r squared, should I say, r squared is going to be equal to 64 minus, and remember we worked out x to be 8/3 squared. All right, so if we do that on a calculator, what do we get, matrix? Please, can someone do that for us and share your answer? (64 minus 8/3 squared leaves us with what?
56,89.
Indeed. All right. Daneo, if you didn't press the SD button, what did you end up with? If you don't press SD though.
512/9.
That's it. Okay, so it's I don't know. I'm just a bit of a hardcore when it comes to that. I prefer not pressing the SD button, but that's quite right. So 512/9 is perfect. Okay, because we should only round off at the very, very end. All right, and then we need to put in whatever h was. Okay, so this was 512/9, perfect. And then remember, matrix, now we need the h on the end. Okay, so what is h equal to? Do you remember we had said that h was x plus 8? Do you remember that? Okay, so in this case, it's going to be 8 plus 8/3. If someone can just work that out for us, please. And again, just leave it as an improper fraction. What do we end up with? Indeed, Karabo. Okay, good job.
32/3.
That's it. Perfect. Well done. So we end up with 32/3. So now we're going to pop in our 32/3 over here. And that is what goes in our numerator. Okay, now as far as our denominator is concerned, we need to sub in there as well, the volume of the sphere. All right, so volume of a sphere, if you recall, matrix, is 4/3 pi r cubed. Let's just double check that. Indeed. Okay, so what should I sub in next? The 8 cubed. Okay. And we're now eventually here at our answer. If we work out what the value of the numerator is, what do we get? Can anybody tell me? Anyone got an answer for the numerator? So on your calculator, you would go, okay, but remember, Silindile, we're working for the numerator. Okay, remember, we're working with a ratio. It has to be whole numbers. Let me double check. I'll see what I got. So in our calculators, we're going 1/3 times pi times 512/9 times 32/3. Okay. Maybe we need to put that all in. All right, so 635,454, 9881. Okay, and that's going to be over. Okay, no, that's fine. Perfect. Let's just do the denominator now. So that's 4/3 times pi times 8. I'm wearing my glasses, cubed. Okay, so that gives me 2048/3 pi. All right, and then let's just double check when we divide the numerator by the denominator. Hopefully we're going to end up with a whole answer. Okay, so 635.454,881 divided by answer equals. Why are we not working out the right answer here? If I made a mistake somewhere, I can't see where I've gone wrong here. Volume of the cone was 1/3 pi. Yes, so that's fine. The volume of the sphere was 4/3. Maybe it's just the way we inputted it into the calculator. All right, let's just try this again. I'm just going to try it on my calculator once more. Ah, there we go. All right. So it was just the way in which we were putting it in. I've entered it just like this into it obviously didn't like it, which is strange. But anyway, it doesn't matter. I've entered it just like this, just like that into the calculator. So if you use your calculator and you use the fraction button, like that. Once you get up to the top here, press the fraction button again, and then it'll give you another numerator, and then you can put in the 1/3 and then the pi and then the rest of it like that. And then when you finish putting it in, navigate down here, press the fraction button again. So then you can put in the 4 and the 3 and then the pi and then the 8 cubed. If you do that, and I mean, I've got it now, I'm looking at it here. I've ended up, this is what I was expecting, was with this answer over here. So I got 8/27. Okay, so the volume of the cone compared to the volume of the sphere is 8/27. Okay, did the rest of you get the same answer as me? Are you getting the same thing on the calculator? Oh, Swelithli, you said you got the same. Good. All right, brilliant. Dineo, yes, lovely. Okay, great. Well done, guys. All right, so sure. Well done, Swelithli. Lovely. Are there any questions? Cool, Timothy. Good job. All right. Are there any questions, Matrix, or can we move on to the next question? I'll take that. We can move on to the next question. Okay, all right. So this is now question 10. So we've moved on to probability now. And in 10.1, the first thing that they've asked us to do, I think, is to draw. They haven't asked us to do it, but I think if we do draw a tree diagram for this, it's going to be very useful. Okay, so they've told us that a bag contains 7 yellow, 3 red, and 2 blue balls. A ball is chosen at random from the bag and not replaced. Okay, well, that's really important. So let's just underline the words not replaced. Okay. A second ball is then chosen. Determine the probability that 2 of the ball chosen, one is red and the other one is blue. Okay, so this question, I think, lends itself very nicely to a tree diagram. Okay, so they are implying here that we are going to put our hand into a bag and either we're going to get a red ball or we're going to get a blue ball, right? The probability of us getting a red ball is going to be what out of what matrix? It's going to be 3 out of 15. Danelle, why 15?
I added up the number of balls, ma'am.
That's quite right. I agree with you, but I can see 7 plus 3 plus 2. So I'd say 3 out of 12. 7 plus 3 plus 2 is 12.
Did I calculate wrong?
It's okay, Janelle. We all make mistakes, but yes, you're quite right. You were supposed to add all the number of the balls together, so that was perfect. Okay, so
Sorry,
I would
ma'am,
say
it's
3.
12. Sorry, ma'am.
No, it's fine. No problem, Janelle. Not to worry. Okay, and then of the 12, we know that 2 of them are blue. All right, so now if we take out another ball, it could either be red or it could be blue. But if we've taken out a red ball already, there aren't still 3 red balls in the bag. There's only going to be 2 of them. Also, there aren't going to be 12 balls in the bag. There's only going to be 11. So that's what happens when things are not replaced. All right. So in other words, your probabilities when you are looking at your second event have become altered because of what happened in the first event. All right. As far as blue is concerned, we haven't taken out a blue, but there would still be 11 of them. Then over here, again, we could take out a red or we could take out a blue. If we take out red, this would be 3 in 11 because we haven't taken a red one yet. And obviously over here, as far as the blue ones are concerned, if I've taken a blue one, there'd only be 1 blue ball left and there'd be 11 balls in the bag. Okay, so that's what I would end up with. Now I want to calculate the probability of the 2 balls chosen. One is red and the other one is blue. So probability of red and so well, it's actually 1 red, isn't it? 1 red and 1 blue. Okay, so here I've got RR. Now I'm going along the branches. Along my second branch, I would have RB. Along my third branch, I'd have BR. And along my last branch, I would have BB. So there's only 2 of these that meet the criteria for my question. These 2 over here. 1 red and 1 blue. I can't have 2 red balls and I can't have 2 blue ones. All right, so it has to be these 2. So what I'm going to have to do is work out the probability of RB and then add it to the probability of BR. Okay, so remember when we go along the branches, we're multiplying, and then when we come down, that's when we're going to add. So in other words, coming down from RB to BR means we're going to add those 2 together. Okay, so that means matrix. We've got 3 over 12 times 2 over 11 plus 2 over 12 times 3 over 11. So 3 over 12 times 2 over 11 is correct, plus 2 over 12 times 3 over 11, 100%. Pop that straight into our calculators, and then we should get an answer. What are you guys getting? Did you get 1 over 11? Oh, really, Silindile? I got 1 over 11. Are you sure you put it in carefully? I'll just double check on my calculator. 3 over 12 times 2 over 11 plus, yeah, Timothy, I also got 1 over 11 plus 2 over 12 times 3 over 11. Silindile, I think you probably just pressed something funny on your calculator. Did you remember to put plus and not times? So this over here is a plus. Let me just highlight that for you. Okay, so this is a plus here. Okay, because we're adding the 2. Yes, Karaba, I agree. I also got 1 over 11.
Sorry, ma'am, I made a mistake. I got 1 over 11.
That's fine. Good stuff. Okay, Silindile, no worries. I'm glad you were able to figure out your mistake and that you got the same answer. Okay, in that case, can we move on, everybody? You can go and have a look at question 10.2. Is it okay if I move it out the way now? And then I'm just going to put this in the middle of the screen for us. Okay, so learners at a hostel may choose a meal and a drink for lunch. Their selections on a certain day were recorded and shown in the partially completed table below. All right, so as far as a meal was concerned, they could have a sandwich or they could have pasta. As far as a drink was concerned, they could have fruit juice or they could have bottled water. So the probability of a learner choosing fruit juice and a sandwich on that day was 0.48. Listen, so fruit juice and a sandwich was 0.48. Now they've told us the probability, all right? How are we now going to relate that to what we see in the table? Let's just see what the first question is. So in 10.2.1, they said calculate the number of learners, cool, who chose fruit juice and a sandwich for lunch on that day. Anybody got an idea of what we would need to do for this question? How are we going to calculate how many students that is? So that they've told us 0.48 of students. How many students chose a sandwich and fruit juice? Okay, we would have to be looking in the first column matrix. So this is where the sandwiches are. All right, so we would have to look at this value over here. So we would multiply 0.48 by 200, and that would tell us how many students. All right, and if we multiply 0.48 by 200, we end up with 96 students. Cool, Timothy, me too. All right, I get the same answer. Is that okay, everybody? All right. Then in the next question, they've asked us to calculate, is the choice of fruit independent of the choice of a sandwich for lunch on that day? Actually, hang on a second. Hang on, wait, hang on. Calculate the number of learners who chose fruit juice and a sandwich for lunch. You know what? I'm sorry. I don't agree with my own answer. That's not right. What we were supposed to do is use this over here, the 250, the total number of students. Okay. Yeah, just reading the question again. Calculate the number of learners who chose fruit juice and sandwich for lunch on that day. Sorry, Matrix, it should be 0.48 times 250. Okay, the total number of students. So that leaves us with 0.48 times 250 is 120 students. Okay, 10.22 is the choice of fruit juice independent of the choice of a sandwich for lunch on that day. Show all calculations to motivate your answer. Okay, so this is a question from grade 11, and they love asking stuff like this. All right, so now we need to go to our formula page, and we need to have a look. There's a formula there that we're going to have to use to answer this question, but we can't set it out exactly that same way. Right? So if events are independent, what does that mean for us? It means that the probability of them choosing a sandwich multiplied by the probability of them choosing a fruit juice is going to be the same of sandwich and fruit juice. Okay, but we can't say that the left-hand side equals the right-hand side. We've got to look at the left-hand side and the right-hand side separately from one another. Okay, so if we work out the probability of choosing a sandwich multiplied by the probability of choosing a fruit juice. All right, so sorry, this is now where we would use the 200. So 200 people chose to have a sandwich. That was out of 250. And how many people chose to drink a fruit juice? That we haven't got, so we need to calculate this first. All right, how are we going to work that out? We need to add these two together. Okay, so this was the 120 from question A. Let's just put that in there. Adding those two together, we're going to end up with 150 in this line. So 150 is going to go in here times 250. Pop that into our calculators, and what do we get as an answer? Anyone got an answer to share? I get 12 over 25, quite right. 12 over 25. If we did press the SD button on our calculator, sorry, it's just when we're working with ratios that we don't really want to do that, we'd end up with 0.48, quite right. Okay, so now let's go back and have a look, right? In our table, all right, this value over here, well, actually, it's not actually a value in our table, it's a probability that they've given to us. It's this one here in the very beginning. Okay, the probability of a learner choosing a fruit juice and a sandwich on that day was 0.48. So that means the probability of a learner choosing a sandwich and a fruit juice was 0.48. So what that means, Matrix, in this case, is that the left-hand side does indeed equal the right-hand side. Okay, so now we are allowed to conclude that the probability of choosing a sandwich and a fruit juice is the same as the probability of choosing a sandwich times the probability of choosing a fruit juice. So therefore, a choice of fruit juice is independent of choice of sandwich. Okay, because the left-hand side does indeed equal the right-hand side in this case. Okay. Are there any questions, Matrix? You sure, everybody? Sure there's no questions? Is it making sense? Are you sure? Is everybody happy? Thumbs ups? Shame you're all so quiet tonight. Is everybody very tired? Okay, let's see if we can zip through this question. We've got 10 minutes left. So hopefully we will be able to get through this one as well. Please ask if there's anything that I've said that doesn't make sense or you want me to go back and go and explain it again. It's not a problem. Okay, so now question number 11. So it tells us that 2 learners from each grade at a high school, so grades 8, 9, 10, 11, and 12, are elected, I beg your pardon, to form a sports committee. All right, so in question 11.1, they ask us in how many different ways can the chairperson and the deputy chairperson of the sports committee be elected if there is no restriction on who may be elected? So what they mean by that is that the chairperson could be in grade 8. The person doesn't necessarily need to be in grade 12. Okay, so, or they could be in grade 9 or grade 10, or, maybe the chairperson is in grade 9 and the deputy chairperson is in grade 12, or maybe the chairperson is in grade 10 and the deputy chairperson is in grade 9. It really doesn't matter. That's what they're trying to say to us. So how many different ways could we choose a chairperson and then a deputy? So in other words, we need to fill 2 boxes. I don't know if your teachers at school teach you to fill boxes, but that's what I always teach my matrics. Okay, well, it's 2 boxes that we want to fill, right? Because each box represents a position. So the first box would represent the chairperson, and the second box is going to represent the deputy chairperson. So how many people could potentially go into this first box? Remember, there's 2 students from each grade. So that means that there are how many ways I can fill this this first box? 10 ways? Does that make sense to everybody? Okay, so 2 times 5, 2 people per grade. So if one of those people have been chosen already, then how many people are left for me to choose from? 9 people. Okay, so it would be 10 by 9, which leaves me with 90. Right. Is that okay, everybody? Okay, I'm trusting that if it's not making sense that you guys will stop me and ask. Please don't be afraid to ask questions. I really don't mind going back and explaining things. It's not a problem at all. Okay, so now it says to us, a photographer wants to take a photograph of the sports committee. In how many different ways can the members be arranged in a straight line? So we love these sorts of questions, don't we? We always want to arrange things in a row. If any member may stand in any position. Can anybody help me here? Or at least make a suggestion. You don't have to help me as per se, but make a suggestion for the answer. How many ways can the different members stand in a row? No one got any idea? Have you all done fundamental counting principle at school already? Is there anybody who hasn't done this? Okay, so let me ask another question, all right? Can there be repetition in this situation, given the context of this question? Can repetition occur? Hopefully everybody is saying no, because we're talking about people, all right? So there cannot be repetition. So in this case, there are going to be 10 factorial ways. All right, so in case you don't know what I'm talking about, 10 factorial means it's going to be 10 by 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. Okay, so when we fill the first position, there are 10 people that are available to take that first position. When we fill the second position, there are only 9 people available. When we fill the third position, there are 8 people available, etc., etc. Okay, so when we multiply 10 by 9 by 8 by 7, we call this 10 factorial. Okay, and the great thing is that you've got a factorial button on your calculator, which means you don't have to write all of that out. Okay, you just have to say 10 factorial. Do you know where the factorial button is on your calculator? It's in the top right. Well, in mine, it's next to my log button. So it should be somewhere in your calculators as well. So if you pop in 10, on my calculator, I have to go shift to activate the factorial. And 10 factorial leaves me with a whopping big number, 3,628,800 students. Okay, or 800 positions. Yes, Karaba, I agree. Okay, so that's the number in different ways that the people can be arranged in a straight line. Isn't that crazy? Just from 10 people, there's over 3 million different ways in which they could be arranged to stand with one another. Interesting stuff, isn't it? Okay, so in this case, they gave us just 1 mark for the answer. Okay, so it would either be that or that, it doesn't matter. So let's do the last question. Oh, we're almost out of time. Oh, let's rush. So, well, not rush, but yeah, we need to finish on time. Members from the same grade must stand next to each other, and the grade 12 members must be in the center. Okay, so now we're putting things together in groups. All right, so what that means for us is that we're going to have to group together the people that were in grade 8. We're going to have to group together the people that were in grade 9. The people that are in grade 12 have to stay in the center. Okay, but they're together as well. Then we've got the people from grade 10 that have to be grouped together. And we've got the people from grade 11 that also need to be grouped together. Okay, so now what we need to consider matrix is this, all right? Within each group, there are 2 ways that the grade 8s and the grade 9s and the grade 10s and the grade 11s and the grade 12s can be arranged with one another. So they can do this, okay? So that's going to be 2 factorial ways by 2 factorial ways by 2 factorial ways by 2 factorial ways by 2 factorial ways. Okay, now they told us that the grade 12s have to stay in the center. So this cannot move. So the only thing that can move are the positions of these bubbles with one another. Okay, so because there are 4 bubbles, there are another 4 factorial ways in which we can arrange the 8s, the 9s, the 10s, and 11s around the 12s in the middle. Does that make sense? All right, so the total number of ways in which they can be arranged is going to be 2 factorial by 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 4 factorial. All right, and if we work that out on our calculators, we end up with, or we could actually just say 1, 2, 3, 4, 5. So 5 times 2 factorial times 4 factorial. No, that's not going to work. Talking nonsense. No, I'm talking nonsense. 2 factorial times 3 factorial. I get 768. Does anybody else get that answer? Okay, so it's 7 o'clock, which means yes. Okay,
Yes,
cool,
ma'am.
Danero. Cool, thanks, Cheeto. I'm glad you got the same answer as me. Matrix, before I hand back to Coco, and obviously I don't want to take up any more of anybody's time, are there any questions? Is there anything that anybody would like to ask me? Okay, thanks, Danero. You sure everything made sense? Yes?
Can I please ask with the first question, question 11 is
Yes.
why did you pick 10 and 9?
No problem. Okay, no problem, Karaba. You can ask me any question. That's what I'm here for, is to help you. Okay, so in question 11, in the very beginning, sorry, I kind of whizzed over this quite quickly. It told us that there were 2 learners. So here, 2 learners from each grade. So in other words, if there are 2 students from each grade and there are 5 grades at high school, it means there are going to be 2 times 5, which is 10 students. That's where the 10 came from. Does that make sense now, Karabo?
Okay.
So that's this 10 over here. Okay,
Oh,
so
okay.
if one person from the group has now been selected as chairperson, there are now 9 people remaining that we can choose to be choose to be the deputy chairperson. So that's why it's 10 by 9. Okay, so again, when we're filling up our blocks, in the first block, we've got 10 choices. For our second block, we've only got 9 choices. So that's why it was 10 by 9. Does that make more sense?
Oh, yes, ma'am. Thank you.
It's a pleasure, Karabo. Anybody else got a question? Are you sure, Matrix? Nobody else got any questions? Okay, well, in that case, I'm going to hand you back to Coco. Thank you for joining us this evening, Matrix. I hope you found that this lesson was useful and helpful for you.
Okay. I'm just going to share my screen quickly.
Thank you.
Pleasure.
Because we also have something to share with you guys. What in the world has happened to my screen? Oh, there it is. I just need to make sure I'm on the right screen. There we go. Okay, guys, this is actually our last lesson for term 3. That doesn't mean we're not going to have any more lessons in term 4. But this is where we are at the moment. You are finally done with your last Q&A for term 3. Well done. And we know that your finals are coming up. So I hope you guys are like amped. You're ready to do it. You know, you wanna, that's why I put this meme here. I love it though. I love the movie. So yeah, so we are actually not going to stop here for you guys. In term 4, we're going to be doing another course, and I have no idea why my things won't change. Okay, we need you guys to diarize the following dates, because what we're going to have is like an intensive final exam prep course for you guys in the next coming weeks. So this is what we're going to have in these coming weeks. On the 11th and on the 13th, we're going to look at stats and fundamental counting principle. On the 16th, functions and inverses. And then we're going to have like a string of dates going through geometry, especially paper 2, because we know that's like bulk of the marks and one of the hardest sections for a lot of matrics. So we're going to be going through that quite intensively. And then we'll look at trigonometry and analytical geometry. And I think literally 3 and the day before your final exam, you can come in and ask any questions that you guys have for the Q&A on that last day. Okay.
Yeah.
Please invite your friends, tell them to get into contact with us, because we're going to be helping you guys just to get through everything required for your final paper. We know you guys want to do well. We actually do still want to hear from you. Tell us how you did in your matric exams, and we're hoping that we can help you guys to get there. So yes, we will communicate this as the time gets a little bit closer, but we will be running another workshop for you guys so you guys can make sure that you're absolutely ready for your final exam. Okay, that is it from our side, guys. Thank you so much. Just need to stop sharing my screen. Thank you, guys. We hope that you have, I think there's like a week break coming up for you guys as well. Unfortunately, if you're in matric, I don't think you guys should rest, or that's just me. Maybe take like a day or two off, but in matric, we hardly ever rest until that very last exam. So this is goodbye. We're going to take a week off. So goodbye from us. We'll see you guys in term 4. And good luck with your studying, guys. Bye-bye.
Bye, everyone.
You're very welcome, Dino. Hope to see you next term. Yes. Bye, Felicia.